Hello everyone and welcome to MakeLearn 360. Okay, so in this video I'm going to teach you um, the polar moment of inertia as well as the um, area moment of inertia of a cylinder, or let's say a cylindrical or a circular area. Actually, it's actually supposed to be a circular cross section. So without wasting much time, let's get started. So first of all, from first principles, we have what we call the polar moment of inertia, dj naught. So dj naught is trying to say that the elemental, polar moment of inertia is given by u squared dA. So the u that you see here is actually supposed to be the radius, but the radius is the whole distance up to here. So u is like, let's say you have a circular cross section and you decide to take a strip. Okay, so in the strip that you took a strip which is like, let's say, a ring. Okay, so that strip that you took is what we have here, which is looking like a ring. So then instead of calling this r, you call it u. So u is like the radius of the small area with thickness du. All right, so what is dA then? So dA will be this elemental area here. So how can you find dA? dA is very simple. You just have to have to stand here and then here. Then you look at this, okay? And then you cut. Now when you cut this and open, it will be of the form like a rectangle. And the distance, which will be the circumference, will be 2 pi u. And then we know that the thickness is actually du. So the area is going to be 2 pi u du. Okay, so think about u as the area of the small circle, the small circular strip. Okay, so now that we know this, all what we are coming to do is to integrate. Don't forget that if we want the actual J naught, so the actual J naught is going to be the integral of the small J naught, which is given by integral of u squared dA. So therefore J naught, which is the polar moment of inertia, will be integral of u squared multiplied by 2 pi du. So now we know that everything here, we know that 2 pi is a constant, is going to come out. Then we integrate u cubed with respect to u. This is very simple. It's going to be u to the power 4 divided by 4. We are actually running u from u equals 0 to r. Don't forget that u is changing from 0 all the way until we get to the radius. So our J naught is nothing but pi over 2 u, which is now r, it's actually 1/2 pi r4. So in fact that is the answer for the polar moment of inertia. So whenever you have a circular cross section and you have been asked to find the polar moment of inertia, that is the formula. But don't forget that we can also use the diameter, because we know that the diameter is twice the radius. So we can say that if we put 2 here, then the polar moment of inertia can also be expressed as 1/2 pi 2r raised to the power 4, which is what? 1/2 pi 2 to the power 4 is actually 16. So 16 d4. Oh, sorry. There is a mistake here. We know that d equals 2r. So r is going to be d over 2. I'm sorry for that. So we are going to put d over 2 inside. Then j naught is going to be 1/2 pi d out of 2 to the power 4, which gives us 1/2 pi multiplied by, so this is going to be d to the power 4 and this is going to be 16. So in other words, what we can try to say, what we are trying to say is j naught is actually pi d4 divided by 32. And this formula gives you in terms of the diameter. So this is in terms of the diameter and this is in terms of the radius. And that formula here is actually for the polar moment of inertia. Let's try and use this formula and get the area moment of inertia. Now this is actually special to only circular cross section. As a matter of fact, the polar moment of inertia is actually Ix plus Iy. However, for a circular cross section, Ix becomes equal to Iy. So we can actually call it I. Therefore, J naught is going to be 2I, which is like saying that I equals J naught divided by 2. So we can say that the area moment of inertia I for a circle or a circular cross section is nothing but 1/2 pi r4. Then we have it again, which gives us 1/4 pi. So 1/4 pi r4 in terms of the radius. So in terms of the radius, we have 1/4 pi r4. And then in terms of the diameter, we have j naught as pi d4 on 32. Oh, sorry, we have I naught, or let's say I, so half. So in fact, it's going to be pi d4 over 64. So please take notice of this. So what this means is that if you have a circular cross section, the polar moment of inertia is actually given by 1/2 pi r4 in terms of radius, and then 1 out of 32 pi d4 in terms of diameter. However, the area moment of inertia of a circular cross section is 1/4 pi r4, and then in terms of the diameter is 1 out of 64 pi d4. Thank you very much for watching.